All right, we are live. So, just so you guys kind of know where we're headed in Honors Algebra 2, the rest of today we're going to take notes over 4-1. Hopefully we finish all of these. Then tomorrow, because of the assembly this morning, tomorrow when you guys come in, we'll just finish the notes if we need to, and then you can have the rest of class time to work on your homework. So, should be an easy 2 days. Wednesday, you guys have section 4-1 day 2, Thursday 4-2 day 1, and Friday 4-2 day 2. So we're 4-1, 4-1, 4-2, 4-2. And then just so you guys are planners, our quiz, now this truly just happened this way. Our quiz is the Tuesday before Thanksgiving. Okay, it just happened that way. Why'd you guys roll your head? Did you guys have a bunch of stuff that day? You're gonna be gone? When are you leaving? That Tuesday. Okay, we're gonna take yours on Monday. Remind me. Anybody who's gonna be gone early, we want to take it early before you go. You do not want to take it when you get back. Okay? So just keep me posted. You're gonna be gone too? Where are you going? Georgia.
Who said that?
So if you are going to miss early that Thanksgiving Tuesday, you gotta let me know because we have a quiz and I do think it would be in your best interest to take that quiz on Monday. Okay? I mean, you don't have to, but that would be my suggestion. Okay? All right. So, chapter 4 is our polynomial chapter, and we are going to go back to graphing polynomials a little bit. But first of all, we need to just talk about what is a polynomial. Okay, what is a polynomial? Well, a monomial, mono, is a number, a variable, or a product of numbers in one or more variables with whole number exponents. So a monomial. For a monomial, you might have 2x squared. You might have 3xy. You might just have 4. Each of those are monomials. Once you start adding or subtracting them together, you have a polynomial. Okay? Do you remember the word degree? Do you remember the word degree from Algebra 1? No? Okay. If I give you this term, this polynomial, 3x squared plus 2x to the 5th minus 5x to the 4th plus 3x to the 3rd minus 2x squared, okay, plus x minus 1. First of all, this polynomial, this is a big polynomial, but it's in standard form. What does standard form mean? Goes from the what? Highest exponent down to the lowest, which is called the constant. So it goes from the highest exponent down to the constant. So this polynomial is in standard form. What is the leading coefficient? That's the coefficient that's out front if it's in standard form. So what's the leading coefficient? What's the coefficient of this term? 3. So the leading coefficient is 3. All right, what is the degree? Okay, the degree of a polynomial is the highest exponent of the variable. So which is your highest exponent? So the degree is 6. Do you guys remember this a little bit? Some of you are like, no. Some of you are like, yeah. Okay. So the first part of your guided notes that you see, you guys have this chart. Okay? And what do we call it if the degree is 0? If I just have a 7, I don't have a variable at all. What do you guys call it? If it doesn't have a variable, it's what? Constant. It's constant. So this first one is called a constant. It does not change because it does not have a variable. Okay. What about this one? I like to look at the example over here. I think the standard form gets confusing. Look at the example, 5x minus 7. If I told you to graph 5x minus 7, what kind of graph would you get? A line. So this is what type of a function? Linear. Okay, next one. If I have x squared in my problem, it is quadratic. We just studied a whole bunch of these. Solve the quadratic. Okay. What about anything to the third? Well, I could say x to the third, or I could say x cubed. So what do you think you call this? Cubic. Cubic. It's a cubic function. Let's see. All right. What if I have a degree of 4? Notice this one is x to the 4th power. If you have a singing group or a musical group with 4 people, what do we call that? A squad, not a squad. Specifically 4 people singing or 4 people playing. Say it again.
A quartet.
A quartet. So this is not a quartet, but quartic. Okay. Now I'm going to add one more to this. I'm going to say, what if we have a degree of 5? For example, what if I have f of x equals 3x to the 5th plus 2x? What's a singing or musical 5 group called? Right now? 4 was quartet. What's 5? Not pentatonic. I heard it. Quintet. So this is quintic. Quintic. All right. What's that? All right. So these are all examples of polynomial functions: a constant, a linear, a quadratic, cubic, quartic, and quintic. Remember, in order to be a polynomial function, you must have whole number exponents. Whole number exponents, meaning 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5. Okay? So as I look at this, the first thing it says is, first, determine if it's a polynomial function. If it is, write it in standard form. State the degree, the type. By type, that means, is it quadratic? Is it quartic? Is it cubic? Is it linear? What is it? And what is the leading coefficient? So there's so much that they're asking you for here. So first things first, is this one a polynomial? Quinn?
Yeah.
Yes, it is. There's no reason it's not. So yes, it's polynomial. All right. Is it in standard form right now?
Yes.
So how would you write that? It's what? Just negative 2x to the 3rd plus 5x plus 8. That's standard form. Okay. State the degree. So what is the degree of this?
Quadratic.
No, the degree is the highest number of the exponent. Okay, so it's 3. Okay, so what would the name of this be? What is the type?
Quadratic.
If it's 3, it's not quadratic. Cubic. And then what is the leading coefficient? What's the number out front?
Negative 2.
-2. So that's everything they asked us. Is it polynomial? If so, write it in standard form, state the degree, the type, and the leading coefficient. Now this one gets a little bit tricky. Sometimes we see that square root of 2, and we're a little confused. Is this a polynomial function? Does it have whole number exponents? Sure does. So is it a polynomial? Yep. She's absent. McKenna. So they're telling you it is. So McKenna, help me get this in standard form. How do we rewrite this using the highest exponent first? We're not subtracting, we're just moving things around. So which term comes first? Okay, so f of x equals square root of 2x to the fourth. Which one comes next? Minus 0.8x to the third. Subtract 12. Next thing it asks you for is the degree. What is the degree? So what do we name it? What's the type? Quartic. And what's the leading coefficient? Square root of 2. Do you guys see how that works? All right. What do you guys think about this one? Is this one a polynomial? What are whole numbers? It says whole number exponent. What are whole numbers? Yeah, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your counting numbers plus 0. All right, those are your whole numbers. Is this polynomial? Why not? Okay, this is not a polynomial. Why not? There is an exponent that is what? That is -1, which is not a whole number. Good? Okay, how about D? What do you guys think about D? Is that one a polynomial? Why not? I agree. Yeah, X could be anything, not a polynomial. X could be anything, right? So that means our exponent might not be a whole number. Okay? Questions? First part of this, pretty simple? Okay. Ready for part 2? Evaluate. This is so Algebra 1. Okay. AJ's like, do you just plug in 3? Guess what? Yeah, they just want you to take this and plug it in where? Everywhere you see an X. So when you do, you're going to do 2 times 3 to the 4th minus 8 times 3 squared plus 5 times 3 minus 7. Now, everybody grab your calculators because I want to make sure you know how to do this. All right, so I'm going to do 2 parentheses, 3 parentheses. How do I raise it to the 4th power? Caret 4 minus 8 times 3 squared plus 5 times 3 minus 7. Yeah, this is easy. Yeah. And what did you guys get? You guys get 98? Okay, so the way you write this, f of 3 equals 98. The value of the function when you input 3 is 98. All right, are we good there? All right, I love this next part. It's fun for me. Not always for you. But I want you to think about something. If I give you y equals 2x plus 3. I want you to think about that a minute. what would the graph of this, we're going to just sit and watch for a minute. What would the graph of that function look like? Okay, my y-intercept would be what? 3. What's my slope? Up 2 over 1. Okay, so my line would look like that. Do you guys agree with that? It has positive slope, and it's linear. Would you guys agree with that one?
Yes.
What if I have negative 2x plus 3? How does that change my graph? Well, I still start at what? 3, but now you go what? Down 2 and or up into the left. So your line goes like that. So you guys remember, positive lines go up and to the right, negative lines go down to the right. Are you guys good with that? All right, now let's talk about, what if I give you y equals x squared? What can you tell me about the graph of just y equals x squared? It's a what? Quadratic, so it's a, what's the shape called? A U, parabola, and it opens which way? Up. Do you guys agree that that would be my parabola? What if I put a negative in front of my x squared? What happens to my parabola? It's flipped. It goes upside down. Okay? This is going to be true for the ends. Now, I'm not talking about what's happening in the middle, but I'm talking about the ends. Okay? Because you may not know this, but if you have x to the third, we haven't really talked about x to the third much, but let's do this. What's negative 2 to the third power? Negative 2 times negative 2 times negative 2? Negative 8. What's negative 1 times negative 1 times negative 1? 0 times 0 times 0. 1 times 1 times 1. 2 times 2 times 2. Do you guys see that this graph would go like that? Okay? What about if I put a negative in front of it? Okay? Well, same thing. If I put in negative 2, a negative times a negative times a negative is a negative, but then I make it negative, so it actually becomes what? Positive. Same thing here, becomes positive, 0. Now when I do 1, what's 1 times 1 times 1? 1, make it negative. Make it negative. So do you guys see that this one goes like that? So notice, when my degree was 3, or what's the degree here that's invisible? Or 1. The ends go in opposite directions, right? My ends. I'm talking about the ends of my graph. I'm not talking about what happens in the middle. If you have an odd degree, the ends go in opposite directions. If the leading coefficient is positive, slope was positive, it went up to the right. If the slope was negative, it went down to the right. Odd, opposite, positive, negative. Go back down to this one. Odd, opposite, positive, negative. Okay? Even. If you have even, the ends go in the same direction. If it's positive, they both go up. If it's negative, they both go down. Let's check x to the fourth power. Just watch. X raised to the fourth. What do you think my ends are going to do here? Both go up, right? It's even and positive. Even and positive. Let's see. Did it both go up? Now, some funky things are happening here in the middle. You can't see it. It actually kind of does a little W. It's really small, but it does. Okay, how about if I put a negative in front of there? Okay, what if I put a negative? What do you think's going to happen? It's going to open upside down. Both the ends are going. We could go on for to the 5th, to the 6th, the 7th. So that brings us to this next slide. Okay, the end behavior. If it is odd. Odd is opposite. Odd is opposite. If the leading coefficient is positive, think about positive slope. I do this. I don't care what's happening in the middle, but I know my ends are going that way. If it's odd and negative, odd is opposite. I know negative slope, it goes this way. Again, I'm not worried about what's happening in the middle. We're only talking about the end behavior, what's happening to the ends of my graph. End behavior. Okay, I left this blank so you guys can write this. You might remember this in Algebra 1. As x approaches positive infinity, and it's just mathematically correct to put the positive in front of the infinity. So as I walk out towards the positive way, which way is my graph going if I have an odd degree and a positive coefficient, leading coefficient? It's going what? Up. Up is what? Y approaches positive. Actually, I think we use P of X in here. F of X. My Algebra 1 uses Y. F of X. Let me cover that back up. Hang on. Okay. F of X approaches positive. The graph goes up. As x approaches negative infinity. So as you walk out towards negative infinity, which way is the graph going? Down. Down is what? Negative infinity. So the graph approaches negative infinity. Guys, the only thing you change is that. This first sentence is the same every time for end behavior. As x approaches positive infinity, f of x approaches what? As x approaches negative infinity, f of x approaches what? So you just have to say, as I go this way, which way is my graph going? That's positive. As I go this way, which way is my graph going? Negative. Let's do this one. So again, as x approaches positive infinity, f of x approaches what? We'll fill that in a minute. As x approaches negative infinity, f of x approaches what? So all I have to do is fill in. That beginning part stays the same every time. You should be filling these in up there. So now we said odd and negative. Odd is opposite. Negative slope falls to the right. So as I walk out in positive infinity, which way is my graph going? To negative infinity. As I walk out towards negative infinity, which way is my graph going? Positive infinity. Do you guys remember this from Algebra 1 a little bit? Maybe not 100%, but at least I kind of remember at least seeing this. No? All right, let's try another one. Let's look at this one. What if I have even and positive? What's gonna happen to my graph if I have even? Well, if they're even, they both go in the what? Same direction. And since it's positive, they both go up. So again, you can see they kind of dash the middle because they're like, we're not really sure what's happening here in the middle. Depends on what the degree is. We'll learn about that later. So as x approaches positive infinity, f of x approaches what? We'll fill that in a minute. As x approaches negative infinity, f of x approaches what? So as I walk out on positive infinity, which way is my graph going? Up. Up is what? As I walk out towards negative infinity, which way is my graph going? Up. Up is what? Cold, they say. Yeah, I'm glad we had 2 days for our notes. How about this? Even and negative. Even, they go the same direction. Negative, they both go what? Down. as x approaches positive infinity, f of x approaches what? As x approaches negative infinity, f of x approaches what? So as I go out towards positive infinity on x, which way is the graph going? Towards negative. As I go out towards negative infinity, which way is my graph going? Does that make sense to you guys? Are we okay? Okay? Let's get the first example done, and that way you guys just have a little bit to do before start your homework tomorrow. Describe the end behavior. Describe. This will be a no calculator problem. Okay? Describe the end behavior. So do not go putting this in your calculator. All right. Is it in standard form? What's the degree? The degree is 4. And what's the leading coefficient? Negative. So, if the degree is 4, is that even or odd?
Even.
So the degree is even. That means that they go in opposite or same? Same. X squared. They go in the same direction. And negative, do they both go up or both go down?
Down.
This is negative. So I just come over here and do this. Like literally 2 seconds. And now I can answer my question. As x approaches positive infinity, the name of this is f of x. So f of x approaches what? As x approaches negative infinity, f of x approaches what? So as x approaches positive infinity, as I'm walking this way, which way is my graph going?
Down. Negative.
As I walk out this way towards negative infinity, which way is my graph going? There's your end behavior. Now, this is just me thinking. Just me thinking. Try another one. Yeah. What's the degree? Everybody, the degree is what? 3, which is odd. How about the leading coefficient? Negative 0.3, so that's negative. So what do we do if we have odd and negative? Okay, odd. Odd, the ends are opposite, and negative, they go, you're fine, you can just throw it away, Jordan. Negative, does it go up to the right or down to the right? So we know it goes something like this. So, as x approaches positive infinity, this is still called f of x, it approaches what? As x approaches negative infinity, f of x approaches what? So let's see if we can get this. As x approaches positive infinity, which way is the graph going? Down, so that's what? As x approaches negative infinity, which way is the graph going? So that's what? Are you guys catching on? Okay, last one. Okay, degree, everybody? 5, leading coefficient? Positive 4. So this is odd and what? Positive. So odd, the ends go in what? Opposite. And positive, it goes which way? Up to the right. So we don't know about the middle. I'm just going to do that. As x approaches positive infinity, f of x approaches what? As x approaches negative infinity, f of x approaches. Okay, as x approaches positive infinity, what's the graph approach? And how about as I go out towards negative? Good. All right. What do you guys think? We still have to finish the last two, which we will do tomorrow. And then you have the rest of class time to work on your homework. Have a fantastic day. Why are you going to get shade? Why are you going to get shade?